Bismillahirrahmanirrahim. How are you, my all dear students? I hope all of you are doing well. Today is my lecture number 3 of chapter number 2 of first year chemistry. In this video, you will learn about most important topic, Dalton's law of partial pressure. Before understanding the word partial pressure needs to be clarified and understand. Students, let's have an example. That group of 4 students have purchased a book by contributing 5 rupees each. The book cost is 20 rupees. Means in 20, this 20 is a total, but each contribution of 5 rupees is partial value. In the similar manner, while having a mixture of gases, there are many gases. Each gas contributes to the total pressure. Individual pressure of a certain gas is partial pressure. This Dalton law describes that the sum of all partial pressure is always equal to the total pressure. Means total pressure is actually due to the contribution of all the individual pressures of all the gases. Look into the example in the diagram. We have mixture of 3 gases, gas A, gas B and gas C respectively. When all these gases are mixed into a single container, their mixture exhibits total pressure Pt, which is equals to sum of all partial pressures Pa, Pb and Pc respectively. To understand its mathematics, you can observe this mathematical work. Students, Dalton's law is very much easy. It's not difficult to understand, but one thing is very important. In exam, if you are required to describe on the basis of kinetic molecular theory, on the screen there is a paragraph. You just learn it, memorize it and write it in your exam. Now, application of Dalton's law, where it is being applied. I'm telling you, in class 9 you have made an oxygen gas on the laboratory level. If you remember, in that preparation of oxygen gas, you have used a method known as displacement by water. In that, what happened, as gas fills into the jar, water comes down into the jar, hot oxygen gets few particles or the molecules of water vapors as well. So that gas jar of oxygen gas contains actually water vapors along with a dry gas. So the mixture is moist gas which contain both dry gas and water vapors. That's why the total pressure of moist gas will be equal to sum of individual pressure of dry gas and water. So by shifting pressure of water from right side to left side, you can have pressure of dry gas by subtracting pressure of moist gas from pressure of water. So this is really very important topic. You can have a good practice. You can have its mathematics as well. Now see this mathematical work as well. We have taken mixture of 3 gases, gas A, gas B and gas C. From PV is equal to nRT, I have isolated T, that is nRT over V. For gas A, B and C respective A, B, C is there. Since PT mean total pressure is equal to sum of PA, PB and PC, by substituting their values, then we have taken common RT over V. So the sum of Na, Nb and Nc becomes equal to total number of moles mean Nt. So the final derivation is there. So in this way, students, you can calculate individual pressure of a certain gas by dividing equation number 1 with equation number 4. Similarly, equation 2 by equation 4. Similarly, equation 3 by equation 4. So these are the actually mathematical steps which are very much easy. I'm not going to describe in this video. You can do it by your own self. The solve equation is there. At the last, my dear students, I request you all to like this video, subscribe this channel, and please share with your fellows. Thank you.